All right, we are on day 4. We're ready to talk about our next quadrilateral, which is a rectangle. And in our warm-up, we're talking about parallelogram A, B, C, D. And it tells us that angle ABC is 3x minus 12. A to B to C is here. It's 3x minus 12. And angle CDA is x plus 40. And they want us to find the measure of angle BCD. All right, so before we get to that, this is a parallelogram, and we know that the opposite angles in a parallelogram are equal. So 3x minus 12 has to be equal to x plus 40. Go ahead and subtract x. We end up with 2x minus 12 equals 40. If we add 12, we end up with 2x equaling, we got 52. And we're going to go ahead and divide by 2, and x is going to come out to equal 26. Except they want to know not just the value of x, they want to know angle BCD. Well, BCD doesn't have an expression. So we're going to have to plug into the angles that we do have. So our x plus 40 is going to become 26 plus 40, which is 66 degrees. This one is also going to be 66 degrees. And if you remember, when we talked about our properties of our parallelograms, that these two angles are called consecutive, and they're going to add up to equal 180 degrees. And so if we have 180 and we take away the 66, we're going to have 114 degrees left for angle BCD. Also, not only does this angle equal 114, but down here, angle A would also equal 114 degrees. Okay, and there's our warm-up. All right, so we got to talk about the rectangle today. So just real quick off to the side, let's not forget about our quadrilateral family tree. So if you're a quad, you just have 4 sides. If that 4-sided figure has a pair of parallel, this becomes a trapezoid. Okay? If that trapezoid has congruent diagonals, okay, also has equal legs, also has equal base angles then, okay, now it becomes an isosceles trapezoid. Okay? If we go down the other way from a trapezoid, we had the parallelogram. It has 2 pairs of parallel and a bunch of other properties. Okay? If we go ahead and take the parallelogram and give him right angles, it becomes a rectangle. So he still is a parallelogram because he still has 2 pairs of opposite sides parallel and all the properties that a parallelogram has. Okay? However, if we take this isosceles trapezoid, we can also connect him to the rectangle. Okay? In that he also has his base angles still being equal, his diagonals being equal. He still has a pair of parallel sides. It's just that his second pair became parallel, and an isosceles trapezoid, when that happens, he becomes a rectangle. Okay? And so they're all kind of connected there. So we have to remember that a rectangle is still a parallelogram, still an isosceles trapezoid, still a trapezoid, still a quadrilateral. Rectangles, all of them so far. Okay? So the way we define a rectangle, it could be a bunch of different ways, but we usually define it as a parallelogram containing one right angle. And they say only one because you only have to give it one. Once one angle becomes right, remember that the properties of all the shapes above is that opposite angles were equal in the parallelogram. Okay? And that consecutive angles are supplementary, and so all of them become right angles then, just by giving it a parallelogram with one right angle. Okay? So it has all 5 properties of a parallelogram. So let's review them. It has 2 pairs of opposite sides being parallel. It has 2 pairs of opposite sides being congruent. It has opposite angles being congruent. However, because it's a rectangle and it has a right angle now, opposite angles are right angles. And don't forget, consecutive angles still have to add up to equal 180. And so those angles now have to become right. So we're going to go ahead and say that all angles are congruent right angles. Okay. And then the other property of a parallelogram is that the diagonals bisect each other. However, in a rectangle, because it's an isosceles trapezoid as well, the diagonals are congruent. All right, so this is still here, a midpoint, but when you take 2 equal segments and cut them both in half, you get 4 equal segments. So this part of the diagonal is equal to this part, just like it was in a parallelogram. But the other diagonal ends up being equal. And so those 2 parts are also equal to those first 2 parts. So all 4 parts are equal. So what happens in a rectangle is if we take a look at one triangle in here, you're going to realize that this triangle is isosceles. See these 2 equal sides here? Therefore, these 2 angles down here would be equal. Okay? If you take a look at this triangle here, it's also isosceles. See the 2 equal sides? So it's also going to have 2 equal angles down here. Okay? So those are a lot of things going on in a rectangle. So we're going to see if we can answer some questions, whatever they throw at us about the rectangle. So in number 1, it says we have a rectangle ABCD. And that AD is 6 and AB is 8. What's the measure of diagonal AC? Well, we can take this 6 and put that up here instead of down there. We can also go ahead, because this is a rectangle, put a right angle in. And so all we have to do is realize is that they're asking us to figure out the length of the hypotenuse of this right triangle. And the hypotenuse actually ends up being the diagonal of the rectangle. And so we're going to go ahead and say a squared plus b squared equals c squared. That's 6 squared plus 8 squared equals my hypotenuse squared. Remember, the hypotenuse is the side across from the right angle. Okay. And when we take 6 squared plus 8 squared, we end up with 100. And we take the square root of both sides, and 100 is a perfect square, and it's equal to 10. All right, and so now we can say that AC is equal to 10. Also, the length of BD would also be 10, since the diagonals are equal in a rectangle. Okay. In number 2, it says in rectangle ABCD with diagonals DB and AC, if the measure of angle DAE, D to A to E is 62 degrees, find all other angles. Ooh, okay. So what we're going to do is we're going to highlight this triangle. And what we have to remember that in a rectangle is that this part of the diagonal is equal to this part, who's equal to this part, who's equal to this part. And so it makes that blue triangle isosceles. And so across from 2 equal sides are 2 equal angles. And so this angle ends up being 62. Well, what you have to realize is that this triangle here is identical or congruent to that triangle there. And so we can go ahead and say that the same 62 degrees are going to happen in there. So this angle will be equal to this one. And you guys can see that those are alternate interior angles to these original ones here. See that Z shape? All right, so this is 62 and this is 62. Okay. Also, we can now figure out the last angle there in the middle. If we have 180 degrees in either one of these blue triangles and we take away 62 and take another 62 away, we're going to have 56 degrees left for the third angle in each triangle. And vertical angles are equal, so that's another reason why those are both 56. And now we're going to focus on these two triangles. They're also congruent to each other. Okay, they are also isosceles. Because again, if I put those tick marks back on the diagonals there, you can see that. This angle here will equal this one. This one here will equal this one since they're across from those equal sides. We also have to remember, because this is a rectangle, this is a 90-degree angle. And so 90 take away 62 is going to leave 28 degrees left for this angle here, this angle here, this angle here, and this angle here. All right. And so now we can go ahead and do the same thing we did off to the side. And each one of those red triangles is 180 degrees. If we take away two 28-degree angles that we already found in those triangles, we have 124 degrees left, which, if you think, the 124 is a linear pair with the 56, they add up to 180. All right, and now we found all of our angles in a rectangle. Tough question, but not bad once you get going, okay? All right, number 3, it says that the diagonals of rectangle ABCD intersect at E if DE is 2x plus 3 and AE is x plus 6. Find the value of x. All right, so this kind of goes hand in hand with what we were talking about before. In a rectangle, all 4 pieces of the diagonal are equal. And so that means x plus 6 has to equal 2x plus 3. We'll go ahead and subtract x. We end up with 6 equals x plus 3. Go ahead and subtract 3. And we end up with 3 equals x. And we found the value of x they were looking for. All right, number 4. It says in rectangle ABCD, diagonal AC is drawn. And it says that if the measure of angle DCA is 30 degrees, D to C to A is 30 degrees, find the measure of angle CAD. C to A to D is here. All right, so if you remember that this is a rectangle, that this is a 90-degree angle, and so in this red triangle that we have here, 180 degrees, take away the 90-degree angle, take away the 30-degree angle, is going to leave us with 60 degrees left, and that is angle CAD. All right, and that is all we are going to do on this day, since on the back side is a proof, and we're skipping those this year. All right, so I will see you guys on the next day of notes.